would you do it on the knot? Let's go! For step 1, the chemical energy from the lighter burns this rope right here, causing the ball to swing.
Step 2. The ball's gravitational potential energy is transferred into kinetic energy as it follows its path.
Step 3. Similar to step 2, the ball has gravitational potential energy because it's raised on an elevation, and as it rolls down the decline, it picks up acceleration and transfers to kinetic energy, exerting an impulse on the ATV.
The conservation of energy continues in step 4 as the tennis ball rolls, hits the ATV, causing the ATV to roll, then hitting the DVD.
Step 5. The velocity of the ATV is greater than the static friction between the DVD case and the table, causing it to fall over.
Step 6. The energy from the falling DVD case transfers into the marble, causing the marble to accelerate down the decline, hitting the Jenga blocks.
Step 7. As the chain of blocks fall into one another, the law of momentum conservation comes into play. One block strikes another in a certain direction while it follows a circular path.
Step number 8. This last Jenga block here contains gravitational potential energy. When the Jenga blocks collide with each other, the last Jenga block falls off the table and accelerates downward at negative 9.8 meters per second.
Just like in the previous step, the chain also has gravitational potential energy because it's raised to a height on the table. And as it swings, it builds up momentum, causing the cup to fall off the table, causing the wheel to rotate.
Step 10. Cup falls, creating a path of inertia perpendicular to the wheel. The wheel turns around the center of rotation. This is referred to as centripetal force.
Step 11. The centripetal force causes the wheel to rotate, causing the needle on the outside of the tire to pop the balloon.
One of our main strengths was the wheel contraption we used to pop the balloon. This was very effective and worked every time. One of our main weaknesses with the project was the spacing between the Jenga blocks which fell down. If they were too close, the Jenga blocks would not fall. So we had to come up with the perfect length in between each block, and it's one block thick, so they would fall perfectly. One thing we could have improved upon with the wheel is the structural rigidity of it. As you can see, there's tape holding the wheel on. This is because the weak copper wire we used here held down the staples broke the night before. So we had to engineer something that would work, and we used tape. So we could have used a different wire which was stronger.